Let's talk about DeepSeek, because it is mind-blowing and it is shaking this entire industry to its core. The emergence.
DeepSeek was the Chinese artificial intelligence model that disrupted the industry worldwide when it emerged onto the scene in early 2025. Creators of the model claimed that it was much cheaper to train than existing large language models, or LLMs. It also demonstrated that open source models that could be fine-tuned and deployed locally by any user could match the performance of proprietary models that are only accessible through AI companies' cloud servers. The market's reaction to DeepSeek's innovation was swift and dramatic, but experts have been worrying about a question that is far more ominous than the sell-off of semiconductor stocks. The question is whether proliferating frontier models that are increasingly accessible and difficult to monitor could be exploited by malicious actors like rogue states and terrorists to produce weapons of mass destruction, or WMD. On March 20th, 1995, the Japanese doomsday cult Aum Shinrikyo carried out a terrorist attack in the Tokyo subway using sarin, a sophisticated and lethal chemical nerve agent. 13 people died. Thousands were injured. Investigators later discovered an extensive chemical weapons program in which the organization had invested tens of millions of dollars employing scientists, engineers, and technicians while building laboratories and production facilities. The organization had to allocate huge amounts of resources to its chemical and biological weapons programs. Even then, not all its attempted attacks were successful. The bottom line is that producing sophisticated weapons of mass destruction is a difficult task for most non-state actors. But with technology, that may be changing. AI models capable of identifying lethal chemical molecules existed even before large language models became popular. But the natural language interface of chatbot-like assistants has made artificial intelligence that much more accessible. A frequently cited early experiment conducted at MIT showed that non-scientist students could use AI chatbots to identify multiple potential pandemic pathogens and the ways to generate them, all in under an hour. To be clear, it is unlikely for anyone to be able to create a lethal pathogen using an AI chatbot alone, but the capability of large language models can be enhanced dramatically once they gain access to specialized bio design tools or are fine-tuned to bio datasets. It is also possible for multiple specialized AI agents to collaborate just as humans do, and there is no theoretical limit to how many such agents could work on the same problem at once. Combine that with non-state actors increasing access to sophisticated tools and materials for genome editing, and the risk of bioterrorism becomes quite real. Prior to the release of GPT-4, OpenAI invited experts on the proliferation of chemical, biological, radiological, and nuclear, or CBRN weapons to help evaluate the model's dual-use potential. The evaluation concluded that access to GPT-4 is an insufficient condition for proliferation, but could alter the information available to proliferators, shortening the time they might have to spend on research and making technical information more easily understandable to non-experts. To address the potential for misuse, OpenAI proposed a preparedness framework by which to evaluate risks related to model-assisted creation of CBRN threats. But not all frontier AI companies have been as conscientious, and there is no national or international consensus on what the legal framework for governance should be. Nor are non-state actors the only threat to be governed. Nuclear war, the ultimate existential threat to humanity. As the largest possessors of nuclear weapons, the United States and Russia have on multiple occasions come close to a catastrophic nuclear exchange, both during and after the Cold War. Some episodes took place at times of genuine tension. Others were largely due to errors and failures in nuclear command, control, and communications. Officials are now publicly discussing artificial intelligence integration with these systems. While most nuclear weapon states have pledged to maintain human control over their nuclear weapons, that commitment is neither clearly defined nor verifiable. Nor does it guarantee safety, considering all the nuclear close calls up to this point have involved human error interacting with traditional systems. At the end of the day, no one can predict all the risks, but a small community of researchers are evaluating the impact of frontier AI on existential CBRN threats and exploring ways in which new AI tools can become part of the solution against the proliferation of CBRN weapons of mass destruction. Machine learning algorithms could help process unprecedented volumes of open source data to detect proliferation activities, from undeclared nuclear research and production to export control evasion. Studies have also found machine learning algorithms capable of predicting nuclear proliferation risks when given large volumes of country data. The private sector and national labs are already pursuing safeguards and security innovations using novel machine learning tools. Meanwhile, international organizations like the IAEA have begun exploring machine vision applications for scanning the surveillance footage of safeguards cameras that monitor worldwide nuclear facilities 24 hours a day to ensure that no nuclear material is diverted from peaceful use. Like nuclear energy, frontier artificial intelligence is a dual-use technology. The question now is not just what these models can do, but who can do it, and for what purpose. The future of artificial intelligence will be shaped not only by scientific innovation, but also by the wisdom that governs it.